energy, and quite a lot of insurance now. So many of the domains kind of people think of. And talking about the talent, I would say that I'm grateful that for last several years, many of the people from Pune University, they worked with me, my team in applied and non-competition, and they're doing awesome. So, first of all, the kind of background they bring in, that's help. So maybe we are in Chennai or agent AI era today, right? We are getting a lot of agents everywhere. But still the background is very much relevant. The basic mathematics or basic statistics knowledge they bring in, that is outstanding. And I believe that a little bit of additional enhancement to what they know, that's good enough, to build some great models or great tools for industry at this moment. For example, I can talk about this life science project that we're working on. We are trying to automate the entire series process, which is kind of a very compact, very strict process in medical domain, pharmaceutical domain. And we are trying to, introduce Gen AI and agent AI. Why agent? Because without human in the loop, it's not trustworthy, right? So that's why agent is very much important. Now, when we try to build this entire agentic AI framework, what we realize is the basic mathematics or statistics background is people bringing, the students bringing, that is equally important to do the validation or to do the filtering, the guardrails around these agents. And that's where, the traditional way of learning or the mathematics statistics that we have learned in universities is very important. Along with the new knowledge like Gen AI and HTTPI that people are moving around today in the digital world.
So we are looking at
Hello, good evening, folks. My name is Ramsu. I have been a data scientist in Detroit for about 22 years now. And I feel concur with the views expressed here. There is definitely a bit of a crisis, but it's a very strange kind of crisis. In the sense that when you look at it from the standpoint of students, they have to have two very, very different skills. One is the ability to slow down and understand the basics and be able to apply it well. And I don't think the value of that has gone away as much as the hype might lead you to believe. Okay. But at the same time, none of us have the luxury of ignoring the big elephant in the room, which is the whole generative AI revolution that we are currently in the midst of. Now, it is, at least my view is that there is at least a certain degree of hype inward that is not matched by the reality of what is being delivered. But at least for a while, investment will follow expectations. It's only later that it will recalibrate the reality, which means that when somebody is hiring, they want to expect some ability to be conversant with these modern tools. Okay. But at the same time, although it may not be explicitly stated, the sustainable success of a lot of these programs are going to involve being able to understand data at a fundamental level very well. So I don't think statistics programs or basic sciences programs are becoming irrelevant. So it's based on two things. So statistics are used data. In some fashion. Okay. The other basic sciences programs will be dealing with fundamental problems which maybe the generators are already talking about. Like if you're working in industrial settings, like you're doing with say a company that makes turbines. Okay. Knowing mechanical engineering, knowing say electrical engineering, knowing a bunch of these things becomes very important in understanding what is doing. That's not going on. Okay. Is the demand for that going to be very, very high? Probably. But is there fundamental demand for that understanding? I don't think that's going to go away. for a while maybe under index, but I suspect that it will also bounce back a little bit when people realize that you can't throw away that entire body. Yeah, I agree with you. Actually, sometimes I feel like, yes, the Python coding part can be automated using agentic AI or Gemini kind of solutions. But what that Python code will do, or our code will do, that I will use. And if I don't understand what I want to do, then it will be garbage. So that means we cannot ignore the basic fundamental things that we need on which, if I'm trying to build a rocket engine, fine, agentic AI may help me to design the rocket engine. But what the agentic AI probably issuing out me 100 designs which is completely wrong and one design which is correct. But I am the one who is probably decide whether this design is correct or not, right? And the story in the media, everybody talks about that. Okay, this agentic AI has developed a rocket engine. Recently, I was reading, but what they never said the failure. How many times agentic AI have failed to produce a correct design? That they will never say. The media will never say. Media will only say how many that it has produced a correct design. But in order to produce correct designs, only 100 times that has failed, right? So, and why that failure rate? Because if I don't know which design is right and which design is wrong, so end of the day, foundational science we cannot simply ignore. I mean that for sure what we are saying. Now, next, obviously, one thing I like to ask the panel that oftentimes when we study, and many of us are also the culprit in that we only study our honors papers, past time, right? And that kind of dangerous because honors paper, statistics honors, or math honors, you're only reading this and probably domain is your biology or computer science or economics, which is actually the domain. And that is where it connects to the actual implementation. So can you make a comment on the importance of slightly not only AI or data science or just a one specialization? Also, the students need to learn few more additional when they're in colleges. What is your requirement in that sense? Um, what I say, as a statistician, usually, we often heard that we can play in immense matter, meaning like our skills are kind of unique in a way that we can serve any person or any project. Just because if there is data, I am able to use the model and that's how the lot of people perceive in the field. So I generally look at it more from generalist versus specialist kind of angle. So, and there is no right or wrong here. A lot of people are more inclined towards a lot of technological developments in the field. Those have not many times engineering type of background. And they are just curious like, okay, today I am dealing with some large language model, tomorrow synthetic system, day after tomorrow there is agentic framework. I will learn it, I will adapt it, and I will see like where I can serve it, right? Whereas over a period of time, a lot of people tend to be more specialists. Right? I want to be focused on certain domain. So for that, if you as a student, as a part of your curriculum, if you have some clarity in your mind, like okay, I can do better in biology or I can do better in economics, please develop this from now itself so that you can start digging down the field a bit more meaningfully, how statistics, how the modeling, how some of these things that we your method of curriculum can be applied more meaningfully to these domains. So I think it's very much important that we look at some of these subjects which are kind of core to a lot of these domains. You name it, economics, biology, they are core to a lot of the developments in their respective domains. If you have some fear of it, some knowledge about the domain, that will definitely help you to kind of contribute more meaningfully to them. Not sure.
Yeah, so I resonate the same with Abhijit. I believe, yeah, exactly. Stats knowledge is definitely required as a background, but domain is important because without that, understanding of the data, which is the basis of your any study, right, that is incomplete, I believe. For example, any domain we have, right? Say retail is quite simple domain. You have your demand, you have your price. You can easily pick a model and say that, right? What would be your next demand? But no, it's not absolutely. Demand is sometimes not equivalent to your sales. The reason is you might have, suppose you're doing some forecasting modeling and say you have used some advanced techniques, say demand sensing models, okay, using the several techniques using random forest and say credit boosting, also LST for example. And you are pretty overwhelmed that the results will be awesome, your precision recall will be fantastic. But still, what you see is that when you try out this model in the real data, you don't have that. So what was this? So suppose there was the demand says that it's zero, right? So is it really the demand is zero or is it because of out of stock? Have you really thought of whether that product is available in your inventory? And that's the reason you couldn't, because of the unavailability, you couldn't sell it. And now you're saying your demand is zero. So that's totally misleading, right? So this kind of information is only possible to gather if you have a little bit knowledge about retail. But without inventory, without this information being captured in your data, the demand model will not be accurate. Same goes with any other domain also. Like for example, if the person doesn't have interest in biology, it would be detrimental to ask kids what are some serious automation that currently one of my project isn't. Because it has so many, internal factors that directly associates with the medical terms. What is adverse event, what is treatment, what is lab reports and all stuff. So little bit of interest and knowledge and intuition is definitely required beside the basic stuff that already we are doing here. Right?
Thanks, Suresh. So, I want to take not a contrarian view, but I want to cover a slightly orthogonal issue here, which has to do with people. That as statisticians or data scientists, we have to talk to people as much as we have to talk to them. Yeah, as much as we have to converse with the data itself. Now, what that means is that we also have to understand what are people motivated by. Okay, and this ends up having very practical considerations in terms of how something succeeds or fails. Give you one example, since these are all statistics that become lost. Basically, where things went wrong. So, we had a problem where we were trying to recommend what products the stores should stock as part of something that we were building for a FMCG company. So salespeople from the FMCG company would go out to stores and they would push the product. Okay? So somebody like Unilever might have 8 salespeople on the street going out to the various stores and say, you need to stock serve different packaging. Right? So if that's what you're trying to solve for, you could build an algorithm, you could build a data science model that says these are the products that you need to recommend. Okay, from the purely data standpoint, it seems perfectly logical to say I'm going to look at what your people have bought before, I will account for what the volume of the stores have bought, and I will essentially come up with patterns on what people need to buy on the basis of this. As a data science problem, it sounds perfectly well formed. What it ignores is the behavior of salespeople and what drives it. A lot of salespeople in FMCG companies, a portion of their salary is essentially incentives that are based on promotions that are being run that month. Which means that for them, there's a much higher incentive to sell the products on which they will get a bonus. So the data that you have historically is going to have that influence implicitly. Okay, and that comes from what motivates them because they're going to be motivated by getting salary. Second, I come up with a bunch of recommendations. You give it to the salesperson. That salesperson is taking it out there. Okay, but they have their own incentive structure for that month, which means that I could have 10 recommendations. The 11th product that's not on the list may be the one that the incentives are aligned. So, what do you think that salesperson is going to say? So, you suddenly realize that if you do not align your solution to the people who are eventually going to use it, then there's a problem. Okay. So part of that could be in terms of things like incentive structures. Part of it could be in terms of understanding the domain and being able to speak the language. Because there may be some decision maker somewhere who needs to eventually sign off on whether or not your solution will arise. If you go to that person and you speak the language of R-squared, you may not be interested. Okay. If you go to that person and say, here's so much money you're currently making, here's how much more money you'll make, or here's how much money you're spending, and here's how much less you could be spending, then they are interested. Otherwise, how does it matter?
Okay, great. So I think the automatic questions that comes with few of your discussion points that the storytelling and do we teach our students how to tell a story? But I want to take that point a little later and I want to again the elephant in the room. An elephant in the room is the question, is anyone going to take our job? With the caveat that I'm a tenured professor, I don't have to worry about my jobs, but the people who are in the industry, they are really worried about their jobs. So how do you take that issue really?
Yes, sorry. So, going back to what initially mentioned, there is an enormous hype around the field, in AI as a field. And this question comes time and again in various discussions, not only in works like this, but even within the organization, setups like us, where some of the industry as using all the developers going to help us cut down certain costs, means resources or people, right? At least in my view, I don't see another to the actually. And I'll give you my rationale by citing one interesting case study that is in the marketplace. So there was this Swedish firm called KLM. Their CEO, when they started their journey, came out publicly and partnered with OpenAI and said that, I don't now need my people who are handling my back office. Close to 400, 500 people they just removed. Saying, okay, all of this work will be done by AI and all the agents that we are building. 1 year down the line, their customer complaints raised so much that the same guy came publicly again to say that I need my people back. I want to rehire, only fire just only people. And you see the underlying thing here is that technology is there for several purposes. If we appropriately put the guardrails in lot of these developments that we currently see in the GenAI space, and we think we can critically, they are mostly helping me improve my productivity. Those are the productivity gains that I can make. So, okay, I don't know better. I want to, quickly respond to my client. I can generate some basic code snippet. I am able to run that code snippet in minimum efforts. So, instead of learning Python from scratch, now I am able to respond to my clients maybe in a couple of hours. That is a productivity gain. But now the same customer, if asking me to justify my results, explain the insights that I am generating, probably this is not going to help me use it. I need to apply my brain, I need to understand the domain, I need to generate those insights, then only I will be able to talk to my client in a much more confidently. So those fundamental skills like the core stats, maths, some algebra, multi-algebra is not going to go away. If you are comfortable doing that, you should be in a very strong position in the marketplace, I would say, from this size. You will be able to get a really nice job. We are looking for that for sure. You understand all these things little better way than anyone else. So I think at least I would say in jobs going away immediately. Okay.
That's great to hear. So, Rishi,
Yeah, I could start with a small story here. So recently I've been to one of our customer site to demo one of our agentic AI model that we have developed. And basically that model is supposed to generate the entire SaaS code, okay, that today's someone is developing or writing. So immediately the reaction, can you believe what was the reaction in the room? People were screaming and saying, oh, you have come to take our job away. So that was the reaction. And we had to take a pause and say that, well, don't worry. It's just to help you out. It's just to improve your productivity for the person who have to do a validation on top of that agentic AI developed code. And no one can do that. So human intervention can do that. Your brain is trying to do that. To do all the validations, to do the guardrails, to do the traceability, everything that is required today in the training area, that is being done by a human and not a simple human. He or she has to be well equipped with the knowledge of analytics and the domain knowledge both, because context engineering is something that is very important. Without context, it is difficult to build any JAI model. You can just use the entire model context, try to build something, but you'll end up with 100 of hallucination at huge cost. No one will buy that model, I'm sure. So, in order to do the balancing, good context, semantic search, RAG, to knowledge graph, all of these things are prerequisite to build any GenAI model. And anyone who comes from a strong stats or maths background with this knowledge, additional knowledge, is really very easy to understand and read, can develop these agents, and their job is definitely safe, secure.
thanks, Rishi. I hope now university managements of all the universities are hearing this, that foundations, the foundational subjects are not going anywhere. It is going to stay and it is going to lead the world around.
Mm. Not only a contrarian view, but I will reframe this slightly. Mm. The normal work that you do, a good portion of it becomes easier to automate when GenAI comes. But it leaves two things on the table. One, like she said, knowing whether or not it's right still becomes a human's job. Okay. Two, as with any Pareto distribution, 80% gets covered by 20% of the cases. But then you have to tell me of the long tail, then nothing. Okay, that still remains a human being's problem to solve. Give you a couple of examples. If you build, for instance, a natural language to SQL solution that says, there's a business leader who wants to know how are my sales in the last quarter broken down by various product categories. It's simply a question that will take any data analyst probably about 30 microseconds to write SQL report for. And it's not a stretch to imagine that a generative AI solution would do that very easy. Okay. But if you complicate that question to a certain point, and you'll suddenly find that the reliability of these solutions is not great. Okay. Now, a GenAI model will very confidently give you the answer. But its confidence in its answer, your confidence in its answer cannot be the same thing. Right. It becomes your job to figure out whether or not you can verify. What that means is that if you are entering the workforce and you are expected to use these tools, your ability to understand whether or not it's doing the right thing has to be much higher. So your understanding of the fundamentals has to be much higher. Okay. Because what an average software engineer could do, an average data analyst could do, now an algorithm might be able to do. So now the expectation is you have to be better than average. Only then will you be able to take that risk. Okay. So I think it doesn't take away jobs yet, although to be realistic, how companies fuel to change. Like for instance, there was a company that paid off a whole bunch of people saying we do it with AI. And there are still companies that face that pressure. If you are, for instance, a software vendor or an analytics vendor, your client is coming to you and saying, hey, you have all these GenAI tools, you have cursor and GitSurf and whatever. I will only pay you half of what I was paying you, do the rest using GenAI. Okay. So you are now in a position where you don't have to lay off people and so on. So there will be a bit of that pressure, and I think the economics of that will take a while to stabilize. Let's not kid ourselves about that churn. But if you understand your field well and you prove yourself capable of taking the risk, then I think your value becomes apparent very, very, very quickly.
Yeah, I think you were right in the sense that some churn will happen because there is an unexpected height and unexpected kind of expectation from AI, and nobody is calling out the it is not AI, it is just it is just a model. And one of the issue is people, I mean, Abhijit was telling me right before the session was starting that, one of the IIT Madras professor recently made a comment saying that, the breach can collapse if the underlying assumptions are not uh, correctly validated by human and correctly relied on AI. So, so there will be some kind of, so that means that human intervention has to be there somewhere. So that means our jobs are to one extent secure if you're really good. That means you have to be really good in your physics and mathematics and statistics and probability. So for the students back there, you shouldn't bunk the class and be better at it. So that is the only way to survive in these challenging times. But you will hear that means you're already good. Uh, and the rest are outside. Um, for the course, because I'm also taking in time, so I think in about 15 minutes at the end, if we have to make recommendations for, I can see completely that one thing we all agree in the room, everybody that foundational science is not going anywhere, it's going to stay, right? Obviously, I think some of our curriculum slightly needs to be upgraded, but I agree with you throughout, and it's not an India problem, India specific problem. I have seen in US also some of the course, the textbook are still 20 years old. That is the same problem, I think, even in Western countries also. So I think academia as a whole needs to be slightly updated itself. So from a practitioner point of view, if you we have to make a require, I mean, pointed, if you say that recommendations. One is I will be discussing that a course which can address that course, and statistical consulting was one of the recommendation that idea. So can you please make a comment on that, whether it will help the academia, whether it will help the students, and how can it be designed?
Certainly, I think statistical consulting type of course will definitely help even we as a university when we want to hire future status. I think that kind of will definitely help. And I think one part that actually goes back to the storytelling, storytelling data or using relation that we use as part of our courses. Uh, with the industry partnerships, collaborations, to this consulting program, I think we can focus more on some of the aspects where students and agencies go through the close collaborations with industry folks like us, where we can experiment with our framework. There are some frameworks like crisp data, so cross industry standard practice for data management. It's a very well thought out, I say, first principle is approach to solving data science problem. So it starts with business understanding, then it comes to data understanding, then we keep exploring the data, then you build the model, and once you are convinced, then you deploy the model. Lot of times this is what happens if we directly jump to build the models because now we have access to the data. We don't think about the business for business understanding, not even the data understanding. We directly jump to build the models, right? So I think through this type of courses it will be very interesting that students actually follow these steps, rigorously and learn some of these skills that we as a industry tend to look at when we actually have. Question?
Yeah, I think the gap is, the theory that we learn in university colleges versus and goes and works with real life data with customer intervention. I feel there are gaps in starting yourself where you have to understand the business problem and convert the problem into an analytical problem. I think so that's something normally when I was a student, when I came out of university and I also had that gap, definitely. Because we are never taught to, understand customers' language. That language is very different from scientific language or theoretical language that we are used to. P-value, for example. No one will understand p-value if we try to explain it, right? How to explain p-value or how to even explain your accuracy in layman's terms. That is something very important. And if the students they get that idea from college life itself, then life will be much easier. That's where this consulting stuff is required because that's the gap.